In this lecture, we're going to learn about named template parameters for Lambda functions. And we're going to try and do something similar to what we did in the last lecture. We're going to set up a simple Lambda function, which is going to take parameters using the auto syntax here. And we're going to return from the Lambda function, and the return type is going to be automatically deduced. What this is going to do behind the scenes is also make a templated Lambda function. But we don't really have enough tools to understand how this is done behind the scenes. We will understand this fully later when we have learned about custom types in C++. But for now, I just want you to see the syntax you can use to make this work better. Because we can do this even if we don't fully understand how it is working behind the scenes. So when the compiler sees the syntax like this, it's going to generate a template behind the scenes. And A, for example, is going to be a separate template parameter, and B is going to be a separate template parameter. The effect of this is that we can call this function using different parameters like this. And if you do this, this is going to work. So it is going to take the first argument to be int, because we are passing in an int literal. The second one is going to be double. It's going to add those up. It's going to get 20.5. And then that's going to be of double type, because the largest type involved in this expression here is of double type. And the return type is going to be automatically deduced to be auto. Okay, so that's what this Lambda function is going to be. But the problem is, sometimes you want to constrain this Lambda function to do operations only on the same type. Because if you mix types like this, it's really hard to keep track of the type of the return type. Suppose you have 10 or 20 types in your expression, it's going to be really hard to know the return type. And sometimes you want to force the compiler to use only the same type for your template arguments here. Okay, so that's what we're going to see, the syntax that is provided by C++20 to enforce that. And the syntax to do that is really simple. All you have to do is put a pair of angle brackets between your capture list and your parameter list. And then inside you're going to put in your template parameters and name them. This is important here. Once your template parameters are named, now you can use them to specify the first parameter and the second parameter. Because they are the same template parameter now, the compiler is forced to only use one type. If you pass different types for this template arguments, you're going to get a compiler error. Okay, now we have this, but we can even go further and put in multiple template parameters if that's what we need for our application. We can do something like this, use different parameters, put in our expression, and the return type is going to be automatically deduced by the compiler. So this is the flexibility we have in C++20. We weren't able to do this in earlier versions of C++, and this will come in handy in any situation where you need to name the template parameters for your Lambda function here. And again, we will have a chance to understand more about this when we have learned about custom types in C++, but we know to use Lambda functions, and I wanted this to be in your toolbox so that you can use that even now in your C++ applications. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is named template parameters for Lambdas. We're going to grab our template files and put them in place pretty quick. We're going to paste them in here, and we're going to open this in Visual Studio Code. We're going to drag and drop on top of Visual Studio Code here. This is going to open up our folder. We can close the left pane. We don't need it. And we're going to clean things a little bit. And we are going to set up our templated Lambda function using the auto syntax here. So we're going to bring in our Lambda function like this. We're going to put in the capture list. We're going to put in the parameters, and we're going to use auto syntax, so auto A and auto B. And we're going to jump into the body of the Lambda function, and we're going to return A plus B. This is how the Lambda function is going to work. We want the ability to be able to call this Lambda function. So we're going to assign it to a variable, and we're going to deduce the type of the Lambda using auto. So we're going to say auto func. This is what we have been doing all along. So we're going to do this, and we're going to put a semicolon, because this entire thing is really a simple one expression. So this entire thing is an expression. The result of this is going to be assigned to func here. Okay, now that we have this, we can call our function. And let's go down and set up two variables like we have been doing all along. We're going to put in A, it's going to be a 5. We're going to put in double B, and that's going to be 63.9, why not? And we're going to do auto result equals func AB. And again, I want you to guess what we're going to get out of this function here. A and B are of different types, so we're going to add them up, and we're going to get something that is really not reliable, in that the type of the expression is going to depend on the parameters that we pass in here. So what is going to happen? The compiler is going to see this and generate a template instance for this Lambda function here. We don't have enough tools to really understand what is going to happen here. For example, if you pass this in CPP Insights, you're going to see that the compiler is going to generate something, but we don't have enough tools to understand this yet. So for now, we're going to think that it is going to generate a function template, which is going to be having the parameters for the parameter we have in the function here and the return type. And these two guys are going to be using different template parameters. So you can think of this as if it was using TA for the template parameter and PB, for example, for the template parameter. The message is there are two different template parameters, and we can pass different things to have an expression in the return statement here whose final value depends on the types that we pass to this function when we call it. I don't really know if this makes sense. So sometimes you need to enforce that code like this is not going to compile if you are passing different types as arguments here. And there is a way to do that in C++20 with templated Lambda functions. But before we see that, let's print this thing out to see what we get. So we're going to say result, we're going to print this thing like we did in the last lecture. So result, and we're going to print the size of the return type because we also want to see this. So we're going to say size of result, and we're going to put this out. And if we compile this, let's do that. We're going to build with GCC. The build is good, so this is valid C++ syntax here. We can bring up a terminal and a run rooster, and we're going to see that the result is really what we expect, 68.9, and the type of the result is deduced to be double. So the return type of this function template here, this is really a function template, but it is a templated Lambda function, we should say. So the return type is going to be automatically deduced, and the rules for return type deduction are the same we have seen before. The largest type involved in this expression here is going to determine the return type of the function here. The largest type is double, so we return double from this Lambda function, and that's what we see here. The size of the result is 8. But sometimes we want to enforce that you only can use this function by passing parameters or arguments of the same type. And we have a way to do that in C++. The first thing we need to do is to name the template parameters. And the syntax we have to do that in C++20 is to put a pair of angle brackets between your capture list and your function parameter list. And then you're going to name your template parameter. We're going to say type name. And for example, we're going to say T. Now that we have this name, we can use it to constrain the parameters we pass to the Lambda function here. So we're going to say TA, let's do that, and TB. And now if we call our function like we do here, you see that we have something like a compiler error. We have a squiggly line in Visual Studio Code. And if we try to look at the problems tab, we're going to say no instance of function template Lambda matches the argument list. Arguments are int double. And the syntax of the function template here is specifying that the parameters should be the same type, and you are passing int and double. So this is not going to work. And if we try and change the types to be the same, for example, we change int here to be double, you're going to see that now this is going to work. And we have a mechanism to enforce for the types to be the same for our Lambda function here. So this is really all I wanted you to see. This syntax we have to name our template parameters when we are using Lambda function with auto type deduction like we do here. Okay, now that this is in, we can try and compile our program. The build is good, we can clear. and run rooster. So result is this, and the type is deduced to be double because the largest type involved in this expression here, return A plus B, is double. If we change, for example, for A to be car and put in a character, literal, for example, C here, and change B to be int, why not, and put in 63, we're going to get the same compiler error. And I don't think I compiled this to show you the compiler error. Let's pass this through GCC and we're going to get a weird compiler error. It's going to say no match call for this function here. And the problem is we are passing arguments of different types when we call this function template. And the signature of the function templates clearly says that A and B have to be of the same type. And we are able to enforce this because we can name our function template here. Okay, so this is the syntax I wanted you to see in this lecture. Another thing I want you to see before we close this lecture is that you can even pass in multiple template parameters if that makes sense for your application. So for example, you can say type name P here, and then say that the second parameter is going to be of P type. Then the error here is going to go away because now the first parameter and the second parameter can be of different types. Now the return type is going to be automatically deduced and we're going to get the result printed here. Let's build this and you're going to see that it is going to work. The build finished successfully and we can clear and run rooster. And we have our result here. The sum is 162 because the ASCII representation of C is some number and we're going to add 63 and get 162 here. And you see that the return type is deduced to be int. We have a size of 4 in memory, so this is int, and it is the largest type between the variables that this expression is using. So that's working according to the rules of return type deductions in C++. This is really all I set out to share with you in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about type traits in C++. Go ahead and finish up here and meet me there.